Now the topic is thixotropy. We are discussing the thixotropy means time dependent viscosity. We are discussing about the time dependent viscosity. Under the time dependent viscosity, majorly three things we come to know. One thing, one is thixotropy, second one is rheopexy, and third one is negative thixotropy or anti-thixotropy. Negative thixotropy or anti-thixotropy. Thixotropy also we can call as a shear thinning system. Also we can call this as a shear thinning system. See why? when you will apply shear, here, shear nothing but shaking. When you will shake the system, this is entangle. Means two polymers are joined at one place. We can call it entangle. This is entangle. When you will apply shaking, when you will shake the system, what will happen means all the entangles will broken. All the entangles will broken and leads to the formation of like this 5 1 2 3 4 5 layers. They will form like that with a little bit gap. Then the system converted from the gel form to the sol form. What is the equilibrium state means? Initial state of the system we can call as a equilibrium state or equilibrium form. Upon applying of shaking, then conversion of sol. When you will keep this system at rest, when you will keep the system at rest, what will happen? Again the gel will form. So here whatever, see 6 entangles are there, means 6 cross linking, 1 2 3 4 5 6. Here when you have shaken the system and when you put at rest, then what will happen? The whatever entangle, loosen entangle, they will reform like this. Entangles are forming, but whatever the system you are getting here, that is not exactly equals to the previous one. See, these are the straight lines, and 6 entangles are there, but here only 4 entangles are there. So this system we can call as a A. This is B. We can represent as a B. Then what will happen means A viscosity of A is more compared to the B. Viscosity depends upon the number of entangles. 6 entangle more viscosity. 4 entangles, 1 2 3 4 entangles, less viscosity. So this B system having less viscosity, A system having more viscosity. System A having more viscosity, system B having less viscosity. Then what will happen? Whenever the system A having more viscosity, see shear rate. See, this is you can consider shear rate means number of RPM per minute is reduced. Whenever the viscosity of liquid A is more, the shear rate means RPM is less compared to the B system. More viscosity, less shear rate, or also called as less RPM compared with B system. So this is thixotropy. See, initially I have the system like this. This one, when I converted at this form, sol is there. Again it is coming to. Again it's turned to the gel form, which is not exactly equals to the whatever the gel form is formed, that is not equals to the previous one. Whatever the gel is formed, that is not exactly equals to the previous one, A system. This is called as a thixotropy. The system must be kept at rest after shaking. But if you shake the system leads to the formation of sol, again you will shake the system, this sol, then immediately formation of gel structure. Upon shaking only, upon shaking only immediately formation of gel. We can call as a rheopexy. I have shaken the system leads to formation of salt. Again I have shaken the salt. What is formed? Immediately gel will form. Then we can call as a rheopexy. What is the equilibrium state of rheopexy? Gel only. What is the equilibrium state of thixotropy? Gel only. But in case of thixotropy, the gel which is formed that is having less viscosity compared to the previous one. But in rheopexy, the gel having same viscosity. This is formed upon application of shear. Upon shaking only it is formed. It is here we are not applying. In thixotropy we are not applying stress. Just one time we have applied. In the second time we are not applying. At rest it is forming. But at second time we are also applying the stress or shaking. Then only the rheopexy will happen. Immediately the rheopexy is immediately gel formation in case of rheopexy. But in case of Newtonian fluid, what will happen means, whenever the system is there, I have applied 1 mg of weight. This is weight. This is cone. Here sample plate. Whenever I have added 1 mg, then 10 rpm it will rotate. 1 2 3 like 10 rpm the cone will rotate. When I have added 2 mg, then 20 rpm will rotate. Then the system will go to the certain point. Again when you keep the system at rest here, then again it will comes to the same initial state. Like see, same initial state. Okay. Here this mark indicating shaking we have applied. This opposite mark indicating when the system kept at rest. Again the same system will form. The system having same shear rate. See here the same shear rate. Whatever the system formed after rest also having the same shear rate like 10 rpm. 1 mg if you add means 10 rpm. 2 mg means 20 rpm only it will shows. But this is in thixotropy. This is the previous one. Once you kept at rest, whatever the formed rest system that is having less viscosity compared to this. But here the viscosity, whatever the viscosity present in the initial system, the same viscosity present in the system which is formed after rest. Examples: plastic flow, bentonite magma. Plastic flow is exhibited by bentonite magma, and pseudoplastic is exhibited by natural and synthetic polymers. Pseudoplastic flow exhibited by natural and synthetic polymers. These plastic and pseudoplastic polymers will exhibit thixotropy, but not rheopexy. Thixotropy exhibited by this. Rheopexy, thixotropy are completed. Next one is negative thixotropy or anti-thixotropy. Next one is negative thixotropy or anti-thixotropy. See, initially I have taken the system that is having solid particle, inorganic. Say magnesium magma. Magnesium means inorganic compounds. See, inorganic compounds initially they will be like this. Inorganic compounds initially like this. See, all these are in the same plane. 1, 2, 3. All these are in the same plane. Symmetric orientation is there. When you will shake this system, leads to the formation of gel. Okay. And when the system kept at rest, see, thixotropy, after shaking, definitely you kept the system at rest. Negative thixotropy, when you will shake the system, then only it will form. See here, first initial state is gel state, then salt, then gel state will be there. Here initially salt state. Salt means solubilized state. Initially the solubilized states are there. Now whatever the particles are arranged symmetrically means in the same line, they have arranged. When I have shake the system leads to formation of gel, See, this is the gel structure here, and this whatever formed gel having little amount of water. See, this is the water. Broken line indicating solvent. Solvent is less here. See, this is whole wide volume. Solvent is present little bit. Here little bit. Less amount of insufficient vehicle is there in gel structure. Then when you kept this gel at rest, what will happen again? The formation of salt. Again the formation of salt. The salt, whatever here formed, the salt is a little bit different from the previous one. Whatever the salt formed here, that is come a little bit different from this. See, these are the parts are arranged same, but the particles are irregular. Particles arranged somewhat irregular. Particles arrangements are irregular. See, compared to this, particles are symmetrical, are aligned in the same line. The particles are aligned in a different line. So this is whatever the salt formed after shaking. After shaking, when you keep this gel at rest, then leads to formation of salt. This salt is completely different, a little bit different from the previous one. See, diagrammatically, symmetric particles somewhat irregular arrangement compared to the previous one. This is called the equilibrium state. See, now we can consider A, B. See, the viscosity of B, the viscosity of A, the viscosity of this A system is less than the whatever the B system. This is the B system. The viscosity of this system is less. The viscosity of this system is less compared to the viscosity of this B. The viscosity of A system is less compared to the viscosity of the B system. Try to remember the very important thixotropy, negative thixotropy, also called as anti-thixotropy. Equilibrium state solved. This is having less viscosity compared to this B system. Example exhibited by magnesium magma and flocculated suspension, very dilute flocculated suspension. In the flocculated suspension also they will form like this one. Flocculated suspension also the flaccules will form as it is like this. Same, the whatever the flaccules they are present, they will form like this. They will arrange like this. The flacula in the flocculated system will also like this. Is about time dependent viscosity. Time dependent viscosity means thixotropy, rheopexy, and negative thixotropy or anti-thixotropy.